If you're converting a raster image to vector, you may wonder what the accuracy or the tolerance of that conversion will be. Well, to answer that, we need to say it depends. It depends on a number of variables, most specifically the quality and the nature of the original image. So we're going to pull in an example here to demonstrate that. We're going to go to Open in ScanCAD. So ScanCAD is raster to vector conversion software designed for the CAD and CAM market. And the CAD and CAM market, of course, really does require accuracy. If you're converting things like these technical drawings, whether they're architectural drawings, maybe mechanical drawings, electrical schematics, could be mapping, GIS maps, whatever they may be, you want to ensure that the drawings are scaled and that it has a good tolerance. So in this case, we're dealing with converting one data type to another. A raster image is an image formed of pixels. We can zoom into this image here and see the pixels. And what we want to do is convert that to vector. So when considering the accuracy, we need to bear in mind the input. In this case, the conversion will be as accurate as possible to the original image, but of course, it can only be as accurate as the original image itself. So if we're giving the conversion software ScanCAD a raster image, then what you'd want is the conversion to trace accurately the original image. That's different to saying, let's say, for example, I want this wall to be exactly 20 feet. Well, that's fine, but you need to ensure that the original drawing has the correct tolerance, the correct scaling, and so on. And then the conversion software can take it from there. So what we have here is a pixel image, as I said. This could be a TIFF image, it could be BMP, PNG, JPEG. Of course, some images are not as good as others. If you're dealing with JPEG images, those are heavily compressed to reduce the file size. And that causes a lot of the distortion in the image and could cause some issues when it comes to accuracy. We've got quite a clean image here. And if we go to File and Scale options, we'll see that ScanCAD has automatically read that the image has a DPI written into it. So this is common if you're dealing with a scanned paper drawing, because the scanner, whether that's a flatbed scanner or a larger plotter, will write the DPI value into the image. The DPI is the dots per inch, or just the number of pixels per inch in the drawing. So if we know the dots per inch or the pixels per inch, we know the physical measurement of the original drawing. So that's really useful. So in this case, we can see that it was 300 DPI. We usually advise that a sweet spot, if you're setting the DPI when scanning the drawing, it should be around 200 to 500 DPI. In theory, if you have a really high DPI, then it will increase the accuracy, but you should only go for that if you've got a very simple image and you're worried about like nano millimeter sort of measurements. So we see the scaling is fine here. If you don't have scaling, that's written into the file. If it's not a scan drawing, and many of the files that you'll pull through ScanCAD won't be scan drawings, then we can input the scaling. To show that, I need to first convert the image. So I'm just going to rush through the conversion. This isn't intended to be a conversion tutorial. I've cleaned the image. We're now going to convert it. We'll go with the presets. It's now running through the conversion. It's doing OCR, converting text. It's now doing the vectorization, and we're done. So we're now viewing what's effectively the DXF or DWG file. I've hit the highlight key just so I can view the vectors highlighted on top of the raster image. If we go to the Both tab, we can view the raster image and the vector image together. So we see, as I mentioned at the start of this video, that the accuracy, the tracing of this is really, really good. We've got two joined vector lines. If we zoom into this wall, and it's gone through the middle of the original image. And if you didn't want it to go through the middle, there may be reasons why you want an outline, then you could edit those settings in the advanced sort of settings here in the line tolerance and object identification. We see also that Scan2CAD has recognized elements as their correct CAD object. For example, this arc here that represents a door has been represented as a CAD arc object. We have text represented as text that can be edited, and so on. We have dash lines and lines. So we have a really good accurate conversion which represents the original image. But you may wonder if the original image represents the kind of accuracy that you want. Well, to answer that, you could use the measure tool. So the measure tool is another way of testing the scaling, but also inputting the scaling. So if you don't have the DPI, what we can do is first, I want to enable snap to endpoints, which means we'll snap to the ends of the vectors. We'll click and drag like so. We can see that we're snapping to the vectors. And let's say that the architect has told me that this wall from this point to this point that I've just measured should be 30 feet. So we'll go to the calibrate. We'll go here, we'll delete these elements. We'll enter 30, we'll hit apply. And now this wall has the correct measurements. In fact, the whole drawing has the correct measurements according to the scaling that we've entered here. So we can now use the measure tool just to measure other areas. Let's, for example, measure this wall from this point down to this point. And we can see that that apparently equals 9.13 feet. So as long as the original drawing is correct, you've now got the correct accuracy, the correct tolerance in the image. Now, conversion software, is important to point out, is intended to get you 90 to 100% of the way. It depends on the nature of the image, how complex it is, and also the quality of the image as to whether you will need to spend 10% of the time editing the drawing. It may be that the tolerance isn't quite right. You need to tweak an arc or a circle. But conversion software should save you days in man hours in the comparison of manual tracing. So we've now got an accurate conversion that I'm happy with the tolerance. And we can go ahead and save this out if we want to. We can just hit the export button, which is a quick export option, and it loads up the DXF and DWG options as well as G-code if you're working with CNC. So that explains the question of how accurate conversion software is when it comes to CAD/CAM applications.